Hello everyone. So today I'm going to start this new series which in this I'm going to discuss the most frequent questions which is asked in grade 10th CBSE exam. So I'm going to start with the real numbers, and the most frequent question from the real number is that to prove that root 2 is an irrational number. Instead of root 2 they can ask root 3, root 5, anything, but the system or the method will be the same. Okay, now the next thing is, before starting this question I want to tell you one theorem which is used in this question. The theorem is that if a is any positive integer and p is a prime number, if a is any positive integer and p is any prime number, then if a square is divided by p, then a is also divided by p. For example, if 16 is divided by 2, then 4 is also divided by 2. 4 is the square root of 16. Okay, so this is the theorem which I am going to use during this question. Okay, so let's start. And I solved this question by contradiction method. So what is contradiction method? Contradiction method is that I assume something and at the end I contradict that thing and then I prove it. Okay, so let root 2 is any rational number. Let root 2 is any rational number. So root 2 will be equal to, is in the form of p by q, where p and q are co-prime integers, q not equal to 0, and HCF of p and q will be equal to 1. So what are co-prime numbers? Co-prime numbers are any two numbers whose HCF is 1. Okay, so now square both the sides. So I can say that 2 will be equal to p square by q square. So cross multiply. So 2q square will be equal to p square. So I can say that 2q square will be divided by 2. And now from equation 1, 2q square is equal to p square, so means p square also divided by 2, and if p square is divided by 2, then as per our theorem p will be divided by 2, and if p is divided by 2, we can say that 2 is the prime factor of p. 2 is the prime factor of p. Okay, now let's go ahead and assume let p is equal to 2k. So what signifies here p is equal to 2k? Here it is p is equal to 2k plus 0. So 2 is the divisor, quotient plus remainder, and p is the dividend. Okay, so p is equal to 2q. Square both the sides. We will get p square is equal to 4k square. And from first equation, because we already proved that 2 is a prime factor of p, now we try to prove that 2 is a prime factor of q also. So instead of p square, from first equation put p square is equal to 2q square. So it becomes 2q square is equal to 4k square. So q square is equal to 2k square, which means that 2q square will be divided by 2 because it has a one factor 2. If 2k square is divided by 2, which means that q square will also be divided by 2, and hence q also divided by 2 as per our theorem, which implies that 2 is the prime factor for q. Now from this and this we can say this implies p and q have common factor as 2, which contradict our assumption. What we assume? We assume that root 2 is any rational number. If root 2 is a rational number, then p and q are co-prime and they have only HCF as 1. But here we are getting another common factor, that is 2. Hence, what we assume is contradict. So, hence, what we assume contradicts here. So root 2 is an irrational number. Okay, it's a quite simply I explain you that how to prove that root 2 or any other number as a rational number. If I take it 3 here, root 3, then instead of 2 here it will become 3, 3q square 3, and p will be divided by 3, like that. Okay, so 2 will be replaced by 3, and here 4 will be replaced by 9. Rest everything will be same. Okay, I hope you enjoy this video. Now I have one request, that it is my new series, so I expect that you can ask me as many as questions you want, and I will create the video for the same. Thank you.